So problem 1 on the literal equation independent study tells you what a literal equation is. So they're equations in which the variables represent specific measures. You most often see literal equations when you study formulas. These literal equations can be manipulated in order to allow you to solve for one specific variable. So here's a common literal equation. It's the formula for converting degrees Fahrenheit to degrees Celsius. So this first part of problem 1 says the normal temperature for the human body is 98.6 degrees Fahrenheit. What temperature is that in degrees Celsius? So we can use this to substitute in. This is degrees Fahrenheit, and that means we should be able to take out the F and plug in 98.6. F equals 98.6, so we can plug that into the formula. So C equals 5/9 times 98.6 minus 32. And now it's just an order of operations problem once you plug in the number. So get out our calculator, type in 98.6 minus 32. And then we need to multiply by 5/9. There's a couple ways your calculator can do that. Say times, and we can either type in parentheses 5 divided by 9. That's the same thing as 5/9. Or we can hit alpha y equals, and that lets us pick a fraction that we can then 5/9. Either way, this will give us the problem. So 37 degrees. So 37 degrees Celsius. So 98.6 degrees Fahrenheit is the same thing as 37 degrees Celsius. So problem number 2 is pretty much the same kind of thing. So you should be able to do this one on your own. It's asking you, what is the temperature in degrees Celsius if your lowest temperature recorded is negative 126.8 degrees Fahrenheit. Okay, now problem number 3 is a little bit different. It says the directions on a box of cake batter tells you to bake your cake at 177 degrees Celsius. And what is this in temperature degrees Fahrenheit? So this time we're going from Celsius to Fahrenheit. So we know C equals 177. And this kind of problem is going to come up in real life. You may get recipes offline that are from countries like Great Britain where they use Celsius. And you may need to convert it so that you know how to do the recipe for your Fahrenheit oven. So C equals 177 degrees. Now we just need to go back and plug it into this formula, but this time we're going to be plugging it in where we see C. So we're going to write 177 equals 5/9 times the quantity of, and we don't know what F is yet, but F minus 32, right? Now, from here we need to solve for F. We need to get F all by itself. So we need to undo what's being done to it, and there's a couple ways we could do that. We could distribute. We could get rid of the 5/9 first. There's several different ways to solve this equation. I think probably the most common way you've seen, though, is to do distribution first. So I don't know that it's the fastest way. So if you want to distribute and then treat it like a two-step, you can. I'm going to show you a different way. What I'm seeing is happening to F is first it's being subtracted by 32, and then it's being multiplied by 5/9. So I need to undo the last thing that was done to it. The last thing it was done to it was multiplying by 5/9. So dividing by 5/9 will undo that. But what I do to one side, I have to do to the other. Now, you could enter this into your calculator that way, but if you remember correctly, okay, so these two things are going to cross out, right? So on this side, we're just going to have F minus 32 now. Now, on this side, this is the same thing, dividing by a fraction. 177 divided by 5/9 is the same thing as multiplying by the reciprocal. So some of this is review about multiplying by fractions. So if I multiply by 9/5, then I will have what F minus 32 equals. So I'm going to type in 177 times alpha y equals 9 divided by 5. And that gives me a pretty big fraction. 1,593 divided by 5. So I'm just going to go ahead and write that like it is for right now. It's not a very practical number, but it's exact and it'll work until we get to the end of the problem where we can round, right? So I'm going to write 1,593 divided by 5. Okay, so now F is being subtracted by 32, so I'm going to add 32 to both sides, add 32 to both sides. And F equals, so I just need to add 32 to this fraction, right? Add 32 to the fraction. And I get another fraction, F equals 1753 over 5. But now that's not very practical. I don't know what that means in terms of degrees, like how cold or hot should I set my oven to, right? So I want to turn that into a decimal. And if I press math and go down to decimal, 350.6. 350.6. Okay, so sometimes it makes sense to work in fractions, sometimes it makes more sense to work in decimals. So 350.6 degrees Fahrenheit. It's the same thing as 177. So rounding, I would probably just set my oven to 350. Okay, is there a more efficient way to determine degrees Fahrenheit than the method you used in question 3? So that's something that you should think about and answer on your own. We're going to go through more of these problems. And when you go through them, you might be able to have an answer that's better. So for number 5, they're asking you to convert the given formula to determine degrees Fahrenheit. So the idea here is really, they want you to convert the given formula. So this might be new language. The idea is to get F alone on the same side of the equation. Here, you have C all by itself. It was really easy to have convert from Fahrenheit to Celsius because we had C all by itself. We just had to plug in for F, right? But down here it was harder because we plugged in for C and then we had to do all this work. So basically, it would make things a lot easier if we had that equation with the F all by itself, right? So here that's basically what they're asking you to do. They're asking you to convert the given formula to determine degrees Fahrenheit, show and explain your work. So that's kind of tricky, but let's write out the original formula. C equals 5/9 times the quantity of F minus 32. The process is really not that different, okay? If we want F all by itself, notice that on problem number 3, we divided by 5/9 on both sides and added 32 on both sides. And it didn't really matter what was over here. The process is still always going to be the same. I could put any number over here and I'm still going to need to divide by 5/9 and add 32, right? And remember, dividing by 5/9 is the same thing as multiplying by 9/5. So I'm going to write that out. No matter what's over here, I need to multiply by 9/5 on both sides, because that would get rid of this. Then add 32. Right? And the whole idea is if I start with C. If I start with C. If I start with Celsius, if I multiply it by 9/5, it would undo this, and add 32, it would undo this, and it would give me Fahrenheit, right? So then add 32 to get Fahrenheit, right? So let me write that out in a formula. C times 9/5 plus 32, right? I need to take the C, I need to multiply by 9/5, need to add 32, that's going to give me Fahrenheit. Now, this I got just from looking over here. But I could have done the same algebraic work to this if I had wanted to. I could have done multiply by 9/5 on both sides, right? And then I would get 9/5 C on this side. And these cancel, and I would get F minus 32 on this side. And then I could have added 32 to both sides. And then I would get 9/5 C plus 32 equals, and these cancel, F. So notice that this and this are the same. Here I explained in words what I needed to do to get the F all by itself. And here I used algebra to show it.